problem, problem 4. Take a look. This is just going back to the idea of the concept of the inverse again. So the monthly cost of a mobile telephone plan is $25 plus a charge of 1 cent per text message. Okay, so we need to find it says, what does it say to do? What's A say? How do you help me out?
Write the linear model.
Right, write a linear model. So that tells us that's going to be linear. As soon as we hear the word linear, we think what? Y equals what? Guys, linear means y equals what? Mx plus b. So as soon as you hear linear, you're thinking, okay, I need to write something that's y equals mx plus b. Okay, so of any y equals mx plus b, then all I need to do is find my m and my b, and I'm in great shape. So, what's my m again? It's my, well, okay, let's do this one. What's my y? Make these different colors. B is my initial amount, my y-intercept. I know it's my starting amount, right? So B, if I'm looking at a graph, folks, if I'm looking at a graph, then B is my y-intercept. If I'm looking at a word problem, then that's the same thing as initial amount. Right? Your y-intercept is your initial amount, what you start with, your starting amount. Okay? And then my m is m is my slope, but what is it in terms of, what does that mean in terms of word problem?
The per.
Yeah, the rate of change. Yep. Exactly. My rate of change. My, in quotes, my per. Does that make sense? Like dollars per hour, gallons, miles per gallon, that sort of thing, right?
That's good.
Okay. Okay, so do I have, I like that. Thanks for bringing that up, Fox. I haven't had people use that before, and that's a good way of doing it, the per. Good. So if you have a mobile phone, is there initial cost you pay no matter what? What's my initial cost?
25.
What did you say?
25.
Yeah, 25. No matter what happens, I have to pay 25 bucks. Everybody on board with that? So month starts off, right away, boom, I'm paying 25 bucks, no matter what happens. That's my initial amount. So my initial amount is $25. This is my, is that my M or my B?
It should be.
Yep, that's my B. Everybody okay with that part? And then what's my rate of change? What's my per?
0.01.
Per text message. So it's 0.01. That's my, sorry, that's my M. Right? So I pay 0.01 per text message. That means that my X had better be text messages. Does that make sense? It's the per what? So, okay. So this means that my function should be then what? Everyone write down what the function should be. Y equals what? Write it down. Write it down now.
It's similar to yeah, you have this, the B's initial amount. And you have the
Equals what?
initial amount.
Am I supposed to use what's your M? Fill in your bag. Sure, either one doesn't matter.
That was the last question. I mean, it took me hours to do that.
I know, I don't know, I'm so used to it. That's how I did it.
Okay, fair enough, as long as you can adjust, that's good. And x plus z. Uh-huh. Yeah. Great, everybody has it. Y equals my m, I know my n is 0.01, x plus my b is 25. Good. All right, so what's the output of okay, so output is my x and my y, which one? What's output? Which one's the input? X. My answer, my output is my y. Okay, good. So everyone take a look at this problem again. What two things are changing in this problem? What two things are changing in this problem? Yeah, maybe I'll erase this temporarily. What two things are changing in this problem?
How much you're paying.
How much you're paying, someone else give me something else. How much you're paying and what? The number of text messages you have. Those are my two variables. Everybody on board? The two things that vary in this problem. How much I'm paying and my text messages. Which one do I generally have more control over? Your text messages. That's typically our x. So then our y would be our, y is our what? What's the other thing that varies?
Dollars. How much you're paying?
How much you're paying. So my y would be how much you're paying. Okay, good. So I think that that is, generally speaking, a really good thing to write down somewhere. The beginning of the problem. And see where your x and your y are. So I would say that you might want to put down y, x equals number of text messages, number of texts. Y equals the amount, the dollar you're paying, right? Or your costs. People usually call it cost, but you can call it the amount you're paying. I don't care. It's all good. As long as you get across the idea. So, what's the output of the linear model? Don't say y. What does y stand for? What is it? Oh, yeah, but in the I'm sorry. So yeah, so y and f of x, those are my outputs. What is it in the context of the situation? When we say context of the situation, we mean in words, like how many cats are being adopted, how many dogs are being walked, the cost of walking a dog. What's it in this case?
The monthly cost?
The monthly cost. Everybody on board with that? Or how much you're paying, whatever it is. What do you want? You can say monthly cost, how much you're paying per month, whatever. Monthly cost, not paying, etc. Any one of those, anything along those lines is fine. Okay, whatever you want to say. So pick something you want to say. Don't write all of them down. Just don't copy what I'm doing. Write down any phrase you want to use that indicates, something along those lines. The amount of money you're flushing down the tubes every month to pay for phone bill. Whatever. I don't care. All right, find the inverse function for the linear model. So let's do this. So here's my function. What's going to happen with the x and the y?
Swap.
They're going to swap. Okay, I will tell you the inverse of, if you want to get rid of, I'll tell you the multiplicative inverse of 0.01 is 100. So keep this in mind. This is like the reciprocal, kind of. So it says reciprocal is is the reciprocal of 2/3 of 3/2. So in other words, it's a multiplicative inverse. What, if I want to get rid of multiplying by 0.01, I multiply by 100, because if I multiply these together, I get 1. So you're going to need that later. Right? How do I get rid of multiplying by 0.01? Multiply both sides by 100. So I'm just going to pause for a second, and then we'll go over this in a minute. Someone asked a really good question, which is, how do I know that the inverse of 1 over is of 0.01 is 100? And the easy way to do that is to say, is just to do 1 divided by 0.01. You'll get 100. Just do that on your calculator, and then you'll know what you need to do to find it. Does that kind of make sense? Okay, so let's take a look. And let's see, the first thing we want to do is subtract 25 from both sides. Oh, do not forget to draw that line down the middle so you keep the two sides separate. That way I know I do it once to this side, I do it once to this side. And I get x minus 25 equals 0.01y. Then I need to multiply both sides by 100. So I'm going to do that. I'm going to multiply this whole side by 100. Multiply this whole side by 100. And I know if I multiply 100 times 0.01, I'll get 1. So I get, on this side I have y. On this side I have 100 times x. And 100 times negative 25, I have negative 2,500. There you go, you're done. F inverse of x is equal to 100x minus 2,500. Voila. All right. Okay, so again, I want to check and see if anybody has any old homeworks that you have to turn in, or a graph of one-on-one functions. Last chance call for these ones to still be on time, and then get out your what we were working on last class, which was the compositions and inverses. We're going to finish that up now.
Did we answer D already?
Yeah. D?
D, yes.
Yeah.
Oh, the D.
D.
Oh,
There's
D.
one more.
Oh, there's D? I'm sorry. My bad. My bad, my bad. There's a D. What's the output of the linear model in context of the situation? Output of the linear model. Oh, what's the output of his new linear model? So what would be the output of, what does Y stand for here? Okay, that was the old one.
Oh,
And it flipped to the inverse.
number.
So yeah, Y, so D, Y stands for number of texts. Per, I love that, per month. Per. Good. Okay. Or I should say each month, because I don't want to confuse with per, because per is the rate. Okay. Good. So let's go ahead and take a look at the, this one here. This is the last one we were working on last class. And remember what we found, which was kind of cool, is that if you do f of g of x and you get x, and you do f of x and you get x, in other words, if you do one function to it and then you do the other function to that output and you get back what you started with, then they're inverses of each other, right? So this means that first I do don't forget, f of g of x, I want you guys to rewrite that as f of g of x. And you can even use your fancy colored pens if you want.
What's the name of this one?
It's called linear functions, inverse and composition. This is the last thing we worked on last class. Looks like this. So pull this one out. Okay, so yeah. Yes.
I think it's
Okay. Oops, my bad. All right, everybody have this? So what that means is, remember our composition is first you do G to it, and then the output of G, you put that into Y as the input of Y. And if you do both of those, then if you get back what you started with, then they're inverses. For example, what's the inverse of adding 3? Subtracting 3. So if I have 100, I add 3, what do I get? 103. If I take that and input into the subtracting 3 function, if I take 103 and subtract 3, what do I get? 100, what I started with. Everybody understand this?
Mhm.
If I want to convert from dollars to pesos, I got 10 bucks, 20 to 1, I get 200 pesos. If I do the inverse function, convert from pesos to dollars, 200 pesos, I get back to 10 bucks. You get back what you started with. Whatever x you put in, whatever you start with, you get the same x back, the same amount back, the same number back. So any number I put into those, if I do both of them, I get what I started with. I get x, right? If you put x in, you get that same x back. Not x plus 3, not x times 2, you get that same x back. That's what inverses do. Are you guys understand this, or are you guys just kind of, it takes longer. So the longer if you guys are not giving me feedback, I will keep talking, and 1 will be boring, and 2 will have less time to review for the exam. So does this make sense, or do people want some clarification?
It makes sense.
I'm not getting to all clarification. Okay, so here's my function f. Here's my function f inverse. If my function f has the point 0, 2 on it, what does f inverse have?
2,
2, 0. Great. That means that if I input 0, I'll output 2. If I take that 2, put that into the inverse, I'll get an output of 0. I'll get back to 0. So 0 will take me to 2, and then 2 will take me back to 0. I get back what I started with. So is that making more sense to folks? So no matter whatever I put in here, someone give me 2 points. I need 2 points.
3, 2.
3, 2. Actually, not with 2 in it.
3, 7.
3, 7. What's my inverse going to be? 7, 3. So if I input 3, it'll take me to 7. If I put it into f inverse, it'll take me back to 3. It undoes it, right? So inverses undo each other. Whatever you started with, if you do both of them, you should get back where you started with, no matter what, right? Because x and y swap, so you'll go from one to the other one, and then swap and send you right back to where you started with. Which should happen. If they undo each other, you should get back what you started with. Okay? Okay. So what it's saying is, if you do the composition, and the composition gets you back to just x, that means that nothing happens to it. I input x, and and my output is x. Nothing happened to it. It did something, it got undone, I get back what I started with. Right? If my input, okay, so what's my input? X. What's my output? Y, right? So my output is y. My input is the same thing as my output. Nothing happened to it. They undid each other. That's what we're saying. Good. Hopefully, that made sense. I don't know. So what we're going to do is use the inverse function test to see if these pairs are inverses or not. So I'm going to do we do this one or not? I thought we did this one. No, we didn't? Okay. So we're going to do f of g of x. So here, f of x, but I want to do, so I'm going to do f of g of x. F of g of x. All right, so what is f of g of x? Well, I need to write the rest of my function, my f function, 1/2, giant parentheses, anytime you see an x, giant parentheses, minus 5/2. All I've done is rewrite the f function, only instead of x, I just put a big parentheses. Whatever goes inside of here, goes there. So what's inside of here? G of x. What is g of x? Not a rhetorical question. What's g of x?
2x plus 5.
2x plus 5. So instead of writing g of x, I'm going to write in what it equals, 2x plus 5. I swear we did this one.
No, you didn't. You did
Okay.
2x plus
Can I get one of these handouts?
Yes, we can.
I found it.
Now, we're going to do what? How do we simplify this? Distribute. That means you take 1/2 multiplied by this part, this term, 1/2 multiplied by that term. There's two terms here, right? 2x is one term, 5 is the other term. So you multiply 1/2 times the first term, multiply 1/2 by the other term. What do we get? What's 1/2 times 2? What's half of 2?
1.
1. 1x. What's 1/2 times 5 is 5/2. If you're not sure, then do it over here. 1/2 times 5, but I need 5 as a fraction. So 5 as a fraction is 5 over 1. And again, remember, you multiply the numerators, multiply the denominators. Five over 2. Okay, and then that's this part here. And then the last part is minus 5/2. I just brought that down. And then if I'm adding 5/2 and subtracting 5/2, they go away. So this is equal to x. Let's take a look at the next one.
So that's done.
Yep, that's done. Well, technically I should try the other way. Try the other way. Do you guys have room in your paper? So now I need to try g of f of x. So that's going to be g. What's g? It's 2, and I see an x, I'm going to put a giant parentheses, plus 5. What goes inside of here? F of x. What's f of x? What's f of x? 1/2 x minus 5/2 plus 5. And again, you're going to distribute. So this 2 on top will cancel out. This is really 2 over 1. It's going to cancel out the 2 and 1/2. So it just becomes 1x. It's going to cancel out the 2 on the negative 5, so this becomes minus 5. And then you still have the plus 5 on the end. So plus 5 minus 5, those cancel out. I'm just left with, should I give us more room? I can try to move these down. X. 2 times 1/2. That's 1x. 2 times -5/2. That's -5. Do you want me to write that in between step? I can do that. And these guys will cancel out, these guys will cancel out. That's better if I do that? Probably not. Can you see that green part when I cancel it out? It's darker on my screen than it is on yours. Okay, let's take a look at problem number 2. Well, I need to find what f of what, guys? What goes inside here? Anyone? G of x, yep. So I'm going to write my f. Write down what f is, only put a big parentheses where x is. Everybody do that. Write down what f is. Only put a big parentheses where x is. So write this. There's a 3 first. So follow along at 3, giant parentheses. Make 3. When you see an x, write giant parentheses. And then plus 4. Do it. No x. Just leave a big giant blank parentheses where x is.
Oh, this is 1/3. Alrighty, so your this is your f as well. So right, calculating your f function, which is 3. Sorry, 3.
That's really small. Okay, so make that a little bigger, because what goes inside that parentheses?
And the parentheses. Like giant parentheses.
Oh, then you right there.
And see how you
Yeah, what goes inside the parentheses? G of x. What's G of x?
This is your f.
Oh, you
1/3 x minus 4.
And don't forget your
Why? Because G of x should go inside of it. I'm skipping a step in there. You guys okay if I skip that step and just go straight to that instead? If you really want, you can do this instead if you like.
So now you just have to do this.
You open up the.
Well, I think it's better if I just do that.
So you just
It's
do
better to leave it like that.
this, and go 1, 2,
Okay, so then you have to do your distributive.
4,
3 over 1 times 1/3 x minus 3 over 1 times 4 over 1. Oh, that's actually easy. We're going to do the parentheses. 3 times -4, -12, and then plus 4. Is this what people have gotten? Yes, no?
Yeah.
So then you have
And then these guys will cancel out. We're left with x minus 12 plus 4. Combine like terms. What do you get?
minus 8.
Minus 8. Yeah, minus 8. So are these inverses? No, because you don't get back what you got it, what you started with. I put in $10, change it to pesos, I come back, and now I have 10 minus $8, I have $2. That's not right. They did not undo each other. Yeah, they did. They totally scammed me. Right, so those are not inverses of each other. You did not get back what you started with.
It's x minus.
Everybody understand what I'm saying?
We started with
I started with x, I got back at the end, after I did both of them, x minus 8, that's not x. Whatever I started with, I got 8 less back. So it's not the same. They did not undo each other. So they're not inverses.
Like this x should be equal to this.
This is not
This x on the same, this is just x.
X.
They're not equal.
I lost lost $8.
Over here. This
So
one should
not
be equal to this.
inverses.
How do you, I don't understand how I know it.
Okay, so this one is going to be x minus 8.
Okay, you guys have one more to do on your own. You're
I
number
don't know
3.
what I'm looking